Test number 3. Problem 1. Explain what each of the numbered items does in the linear search. This item up here, item number 1, is the first part of the while loop, and I is the current item we're on, length of the list, number of items in the list. Therefore, this first part loops until we've run out of items in the list. Number 2. This takes one item out of the list, item 0, 1, 2, 3, depending upon the value of I, and compares it to our key, Morgana the Shrew. Item number 3, this advances to the next item in the list. So, number 3, by doing I plus equals 1, it increases the index, which causes us to advance to the next item in the list when we take a look at it right here in the number 2 condition. Problem number 2, in the linear search above, explain or show how to tell if the element was found or not. That's pretty easy. All you need is to take a look at this. This sees if we run out of elements. Therefore, if I is equal to, so if you've got an if I is equal to the length of the name list, then you've not found the item because you've run out of items in the name list. So, not found. If a list has 300 elements, in the best case, how many elements would the computer need to check before it found the desired element? That would be 1, because it would find the element, best case, first item it checked. If a list has 500 elements, what is the worst case? All 500 elements. That's the last one we look at. If a list has 150 elements, how many elements would need to be checked to determine the desired element does not exist using the linear search? 150. Because you'd have to check every element to see that it doesn't exist. If a list has 800 elements, what would the average number of elements be that the computer would need to check before it found the desired element? Key here is average, and that would be 800 divided by 2, because if n is equal to 800, and it's n over 2, which would be equal to 400 elements on average, assuming an even distribution. Explain how the upper bound, lower bound, and middle position work in a binary search. Well, in a binary search, if you're searching from element 0 to 128, you're going to start with a middle position here, and this will be your lower and your upper. Then you might switch and have your lower here, middle, and upper here. Then next time through, so forth. I need some sort of explanation like this, drawing pictures, words, explanation, whatnot, long as I'm pretty sure that you know what it means. Explain how to know when the upper bound moves and when the lower bound moves in a binary search. You move the upper bound down to the middle element when your middle element is larger than what you're looking for. So if we've got this, our middle element's here, we would move the upper down to the middle element if we check and see that the middle element is greater than the key, and you know that the key is in here somewhere. Therefore, you can move the upper bound down, and you check knowing the key is somewhere between these two values. You don't have to check every element up here. We only checked one element, that middle element. We can completely discount all of these as long as our list is in order. If a list has n elements, in the worst case, how many elements would the computer need to check before it found the desired element? Log base 2 of n. If n is equal to 256, log base 2 of 256 would equal 8, and so forth. It's just a way of reversing 2 to the 8th. Under what circumstances would a linear search work well, but a binary search would not work at all? If our list is not in order. The binary search assumes the list is in order. We don't always have an ordered list, and therefore we would not always want to use a binary search. Given the following grid of numbers, write the code that would print the cell that contains number 5 right here. Wow, look at that. I made it really easy for you. Column, row, and Python goes row first, column next. Therefore, if I want to print, it's going to be print row, which is 0, of the what? I need a variable name for this. I'm going to call it grid, because I didn't seem to specify it. We'll say that this is equal to grid. Grid 0 and column 3. Write code that would set the cell that contains a 1 to the number 3 instead. Okay, there's our 1. Row 1, column 3. Grid row 1, column 3 equal to 3. Write code that would set each cell to the number 5. Oh, much more difficult. For I in range 5, for j in range 5, grid I j equal to 5. There are 5 rows, 5 columns, therefore I want a range from 5, and I'm going to use that as my index locations. That'll set all 25 locations to the number 5. Explain 2 points about the following code. Creates a class. The class's name is customer. Derives from a parent class called person. There are 3 things I just explained. You need 2 of those. Explain 2 points about the following code. This is going to be a method. It's a constructor. It is run when the class that is contained within is first called. It is probably derived from customer, and this right here calls the parent class as the first thing that the constructor does when it is created. So there's quite a few things. You need 2 of those. How does a programmer create his or her own library file in Python? If you want to create your own library file in Python, you're going to need to create a file, and then you're going to need to import the file name. There's a lot more you could say, things like it should not have a py on the end of it when you do the import, but it does need to have a py when you create the file, and that they need to be in the same directory, things like that. Write a function that takes 2 numbers and returns true if they are less than 10 of each other. For example, 10 and 15 would return true because they're 5 apart. 20 and 40 would return false. 10 and 20 would return false, blah, blah, blah. All right, let's go ahead and write that out. Okay, I need to create a function. I'll call this def, and I'll call it close to see if we're close. I'll need to take in 2 parameters. I'm going to call those x and y. Okay, I'm partway there. Are they within 10 of each other? Well, I can find the difference. Now, I could either have a number greater than 10 or less than negative 10, and then it would be false. Therefore, I need to do a check for both conditions, and I can do something like if diff greater than 10 or less than negative 10, return false, else return true. There are a lot of different variations you could do. That's one of the simplest. Write code for a function that will take in an array and set each element to 0. I'll call this 0, maybe. And here's my array. I'll call it my array. For I in range the length of my array. Don't forget that length part there. My array position at I is equal to 0. That's really all there is to it. 3 lines of code total, 1 for the function definition, 2 to set everything to 0. You can't do for item in my array and then set item equal to 0, because remember that works with a copy and it won't change the original array. In fact, it won't create an array at all, and our original array will be left alone. This, however, will work and it will zero out the array. Write code that creates a class called ball. Give it one attribute and one method. Class ball, one attribute, one method. Whoops, what am I forgetting? That's right, I need to have self in here. And it needs to do something. You can't just leave that alone. Functions actually need to have something in them. There we go. Creates a class called ball, one attribute, and one method. Write code that creates an instance of ball. Set the attribute and call the method. All right, b equals ball. This creates an instance of it. Set the color. And then call the method. There we go. And that's all there is to it.